So when you get to A-level maths, a technique you want to be really comfortable with is expanding brackets. Now people have different ways of remembering this. So if you had two terms in X maybe multiplied together like that, some people remember things like FOIL, which is where you do the first, the outer, the inner, the last. The way I like to remember it is just consider the first thing in the first bracket, so just this X, and then multiply everything in the second bracket by X, so you do X times X and X times 2, and then you consider the second thing in the bracket, this 3 here, and multiply the whole of the right bracket again by that 3, so 3 times X and then 3 times 2. We'll just do a few examples because I think that's the easiest way to explain this. So let's start with a bit of a longer example. So if you had x plus 4 multiplied by 3x plus 2y minus 8. So in this case you have 3 terms in your second bracket, but that doesn't really change anything. So again, we can just consider multiplying the whole of the right bracket by this x, so we'd get 3x squared plus 2xy minus 8x, and then we can consider multiplying the whole of that bracket now by the 4, so we'd get plus 12x plus 8y minus 32. And then if you simplify this down, we can collect a few like terms like these x's, can't we? And you'd end up with 3x squared plus 4x plus 2xy plus 8y minus 32. Okay, another example where we might have to use expanding brackets is when we're expanding kind of squared brackets. So if you had 2x minus 4 all squared, we can obviously rewrite this as 2x minus 4 multiplied by itself, and then this just becomes an expanding brackets problem again. So if we multiply everything through by the 2x in this left bracket, we get 4x squared minus 8x, and then if we multiply everything through by the minus 4, then we get minus 8x plus 16, and then we can again collect these terms in x, so we get 4x squared minus 16x plus 16. And with squared brackets like this, your two middle terms, or your two terms in x in this case, will always be the same. So that's just something useful to remember. Now the last one I wanted to cover is when you have something cubed. So let's say we had x plus 2 cubed. There are a few different ways we could think about doing this. The first way is we just again think of it as 3 brackets all multiplied by each other, and in this case we could expand 2 of these brackets, so you'd end up with something like x plus 2 multiplied by x squared, and then plus 2x would be plus 4x, and then plus 4. And then we could expand this like I showed in the examples before. So we could have x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. And if we collect our like terms again, we'll end up with something like x cubed plus 6x squared plus 12x plus 8. Now, a topic you'll get to later in A-level, or you might already have done if you're looking at this video, is the binomial expansion. So if we have x plus 2 cubed, we could also think of doing this as a binomial expansion, which will probably be much quicker. So in this case, we take the first term and we multiply it by 1, and we do that first term cubed, and then this second term is essentially raised to the power of 0, so that just becomes a 1. And and then we multiply the next term by 3, so that's like doing 3 choose 1, and then we get 3x now squared, and this 2 to the 1, and then we get 3x just to the 1 now, multiplied by 2 squared, and this last term, again, we don't need the coefficient of the last term is 1, and then we multiply that by this x raised to the power of 0, which again would just be 1, and this 2 cubed, and as you can see, that should give us the same answer as above, so we'd get x cubed plus 6x squared plus 12x plus 8. So yeah, that's just another way you could do it, often with powers higher than or equal to 3. This would become a more favourable method, just because it's quicker in terms of collecting your like terms.